We didn't start intrinsic extrinsic. Barinder, what are the application of semiconductor in real life? Application of semiconductor. Answer fast, fast. Next, Pratigya. Which type of current is used in the electronic device? Chandana. What is the conductivity range for the conductor?
So for conductor,
Yeah.
सर मैं क्लास अटेंड नहीं की थी कल.
हाँ ठीक है. वीडियो भेजा था मैंने इसका.
for conductor 0.
Conductivity is very high for conductor. Conductivity is very high for the conductor.
Yes, sir. Energy gap is 0.
Energy gap is 0. Sarah, what is the impact of the temperature on the resistance in case of conductor?
Sir, if temperature increases, then resistance also increases.
And resistivity?
Resistivity also
And
increases.
conductivity?
Decreases.
Yeah. बरिंदर तुमने कल अटेंड की थी क्लास सेमीकंडक्टर? I think she has some network issue. Chandana, what is the alpha value for conductor, insulator, and semiconductor?
So 10 power minus 6 to 10 power 5.
Alpha
For
value is positive or negative? Is alpha value positive or negative?
so positive.
Alpha value is positive for conductor and for insulator and semiconductor negative. Sarah, when it comes to the energy band, what are the different type of band we have in case of atom?
The valence band and conduction band.
And what is the difference between these two?
Sir, in conduction band, there's high energy band, and it conducts. It contain conduction through electrons, and
Yeah.
then it is either empty or partially filled. The electrons are responsible for current, and for valence band, electrons are not responsible for the conduction of current. It's
Correct.
either partially or fully filled,
Hmm.
and it has lower energy band.
Okay. Chandana, what is forbidden energy gap?
हेलो सर.
हेलो बरिंदर.
सर अभी
आवाज नहीं
आवाज
आ
आ
रही थी
रही
क्या?
है?
हाँ
नहीं मुझे तो आ रही थी, आपको नहीं आ रही थी.
हाँ. तो क्या कल की क्लास तुमने अटेंड की थी?
यस सर, की थी.
हाँ. तो बताओ फिर फोरबिडन एनर्जी गैप क्या होता है?
सर एनर्जी गैप बिटवीन टू वेलस वो बैंड और कंडक्शन बैंड.
हाँ. एनर्जी गैप बिटवीन द conduction band and valence band, or we can say what is the minimum energy required to jump electron from the valence band to the conduction band, also known as band gap. Chandana, what is the difference between the band gap of a conductor, semiconductor, and insulator?
So energy gap for conductor is 0. For insulator, it is greater than 3 electron volt, and for semiconductor, 1 electron volt.
Okay. So it is overlapping, so no energy gap or band gap in the conductor. In insulator, more than 3 electron volt, and semiconductor less than 3. less than 3, usually around the range of 1. Okay, so this is what we did in the last class. Now we can move to the next topic, and topic name is intrinsic semiconductor or pure semiconductor. Intrinsic or pure semiconductor. Intrinsic or pure semiconductor. So when we talk about this semiconductor, what happened in this situation? Why semiconductor are pure? Because they don't have any impurity. So in this case, you will see no impurity. What does it mean? You have example silicon and germanium. Example, if you take silicon, so there is only silicon, nothing else. So all electron are completely binded. There is no free electron, no hole, nothing like that. Okay. So no impurity in this case. That's why you will say complete covalent bond. Correct? Complete covalent bond, because there is no free electron. All electrons are bounded. That's why conductivity will be no free electron. Conductivity will be less. Why conductivity is less? Because we know there is no free electron, and current is always because of the movement of current. Correct? So, Pratigya, what is current? Pratigya, what is current? Pratigya, are you there? I think some network issue.
हाँ sir.
So what is current? जल्दी जल्दी बोलो.
बस ठीक से नहीं बता पाऊंगी.
फिर ठीक से जो आता है वो तो बताओ. जो आता है वो ही बता दो, बहुत है. So current is basically the movement of electron. When charge move in a given time, means speed of the electron is basically current. And you know current always move from the positive to the negative charge. बस इतना ही था. So what happened and what I wrote after that? If we know there is no impurity, complete covalent bond. If complete covalent bond, no free electron. And because there is no free electron and no conduction, because they are acting as a perfect insulator, so what will happen? No electron will be present in case of conduction band. So conduction band is completely empty and valence band is completely filled. Okay, but example, in this situation, if you heat, then there will be thermal energy. In case of thermal energy, some bond may break. Okay, any doubt? And if some bond break, then there will be free electron. It means if you increase temperature, then you know thermal energy will be more, and if thermal energy is more, some bond break and there will be conduction. Okay. If it is perfectly insulator, if it is perfectly insulator, it usually happen at very low temperature. Example, if you take temperature 0 Kelvin, so it means there is no thermal energy because no temperature. No thermal energy, it means uh, element or semiconductor will be the pure form, perfect form, no conduction of electron. Any doubt? Any doubt, guys?
No sir.
No, sir.
So when you provide thermal energy and bond break, what will happen? Electron will be free. Correct? You will get free electron. And when electron get free, it will move and there will be current. Correct? But at the same time, when example, it's like you had this situation, there was a bond. Whenever you free any electron, it will leave some vacant space behind. That vacant space is known as what? Hole. So if anybody asks what is hole, hole is the vacancy of electron. Hole is the vacancy of electron. When electron vacated their space, the vacant space will be known as the hole. So that's why you will say कि whenever there is a bond breakage, then in this situation you will say कि electron and hole will be produced in pair. Okay, electron and hole will be produced in pair. That's why you will say कि whatever is the number of electron, same number of hole will be present in case of intrinsic semiconductor. Okay, any doubt? So if I am representing Ne is the number of electron and NH is the number of holes. Sara, what will be their relationship?
Sir, number of electrons will be equal to number of holes.
Number of electron will be equal to number of holes. Why? Because intrinsic, whatever bond break, you tone tha. You tone tha. So whatever bond break, then what happen? Same number of electron and holes are released in this case, and that will be the total number of intrinsic carrier. That will be the total number of intrinsic carrier. I means intrinsic. Any doubt, guys? This is very, very, very important when it comes to the intrinsic semiconductor. What you need to take care about? Ki there is no impurity. One specific word, no impurity. No impurity, no special bond. Whenever bond break, then electron and holes are produced and their number is same. So if there is some current, it will be because of that. Understood? If you calculate total current in this situation, Barinder, what will be the total current? Current because of the electron and current because of the hole. Yes or no? Any doubt? Barinder?
No, sir.
Yeah. Same way, if you want to calculate conductivity in this situation, so and conductivity is represented by this. So can you say conductivity will be uh, conductivity because of the electron and conductivity because of the holes? Any doubt? So this is current because of the both. Same conductivity because of the both. As simple as that. So these are the thing what happen in the pure semiconductor. What are the internal property, like chemistry wise property of the semiconductor? That's why when I'm talking about the properties of semiconductor, basically I'm talking about internal property, not external, because physics is more about external, but chemistry tell about the internal behavior. So you will feel like now we are doing chemistry of the semiconductor because we are considering individual atom. Pratigya, what are the element that use as the pure semiconductor?
Aluminum wires.
What?
So what is the question?
My question is, what are the pure semiconductor we use? Pratigya Babli. Silicon and germanium. Like we should always have clarity, all of you, about this key. These are the two pure form of semiconductor, and both have 4 electrons in their outermost shell. Okay? Both have 4 electrons in their outermost shell. So when we talk about this pure semiconductor, what happen in case of semiconductor, Chandana? What will be the impact of the temperature if you increase temperature? I am writing same thing again. If you increase temperature, what will be the impact on the resistance and conductivity?
Sir, increases.
What increases?
Sir, resistance increases.
Resistance will decrease because high thermal energy,
Oh,
more
yes.
electron and holes will be produced. Resistivity,
Increases.
if resistance decrease, resistivity also decrease because it is the resistivity related with the resistance. What will be the impact on the conductance? Chandana,
Sir, conductance increase.
increase and conductivity?
Increases.
Yes. So whenever resistance and resistivity decrease, then conductance will be ulta. Right? Then what kind of bond is present in case of semiconductor, Sara? Sara, what kind of bond is present in case of semiconductor?
Covalent bond.
Covalent bond. So we have covalent bond along with crystalline structure. Barinder, what is the meaning of the crystalline structure? Barinder, what is crystalline structure? Pratigya, what is crystalline structure?
नहीं पता जो
Okay. So guys, crystalline structure mean it's solid that have well packed atoms. If atoms are regularly arranged in proper 3D order, then you will say that this is the crystalline solid. Okay. So if atoms are randomly packed, such solid are known as amorphous solid. Uh, Chandana, where you have this amorphous word in your syllabus? Anywhere you have heard about the amorphous word?
Chemistry.
Chemistry where?
Calcium
Calcium,
carbonate.
calcium carbonate. Have you heard about centriole, amo- pericentriolar in centrosome, pericentriolar amorphous material?
Yes, sir.
Correct. So whenever you hear any term, always correlate. In this crystalline packaging, there are different type of packaging. If consider a cube and atoms are present on the every wall, like you have total 6 wall, 4 side wall, 1 roof, and 1 floor, like that. Okay, if atom are arranged like that, it is known as face-centered cube, a cube that have atom arrangement on the face. Okay, next property. If you add impurity, what will be the impact, Sarah? If you add small impurity, what will happen?
The
Conductance,
conduction will increase. It will
conductance increase,
increase.
change, it increase usually. Correct. Barinder, what is the group number of pure semiconductor?
13.
14. 13 is boron family. Boron, aluminium, gallium, iridium, and thallium. Correct. All of you remember, it's absolutely fine always to don't like if you don't know the answer, because if you don't know the answer, probably I'll tell you more. Example, now if you answer ki, okay, group 14, probably I would have missed this. But because here I feel ki I need to tell this, so this is the group 13. Boron, aluminium, gallium, iridium, and thallium. Group 14 is carbon, silicon, germanium, tin, and lead. And last, nitrogen, phosphorus, arsenic, antimony, and bismuth. We really need all the three groups in our semiconductor topic. Why? Because in this situation, you will understand how we gonna utilize this. Okay. How? Example, group 14 is the balanced state. You have 4 electrons, all can form the covalent bond easily. If you add group 13, then there is a shortage of 1 electron. And if you add group 15, there is an extra 1 electron. Understood? Shortage of 1 electron in case of group 13 and extra 1 electron because you need 4 for the bond. You are getting 5, 1 extra electron. In group 13, you need 4 electron for the bond, covalent bond, but you have 1 shortage. So shortage of electron means vacancy of electron. It means hole. Understood, guys? Hey. Next, if you see forbidden energy gap, FEG, or same thing is also known as energy band gap. So this range can vary from 0.1 to 3 electron volt because we said more than 3 electron volt is insulator. Before that, semiconductor. Correct. Pratigya, what could be the charge carrier in case of semiconductor? Electron and hole. More electron in case of group 15, more hole in case of group 13, and in 14, equal. Any doubt? So tell me, Barinder, what are the example of pure semiconductor?
Silicon, germanium,
Silicon and germanium. Yes. So example, if you take germanium, in case of germanium, Pratigya have network issue. Hmm. हेलो प्रतिज्ञा आवाज आ रही है
हाँ सर
hmm. Okay, so in case of germanium you will see band gap is 0.7 electron volt. In silicon, Chandana, will it be more than 0.5 or less than 0.5?
थोड़ा ऊपर दिखाएंगे
पैसे लगेंगे 10 रुपए एक्स्ट्रा
So less than.
So comparison is really important, not the number, but as you move down the group, then electron can easily remove. Ionization enthalpy is less. As you increase the size, electron can easily move. When electron can easily move, then you need less energy to move electron. Make sense? So down the group, as size increase, electron are loosely bound from nucleus, can easily move. You need very less energy to remove them. Understood?
Yes, sir.
Okay. So it's not only here. Wherever you see, write this ki if you increase size, then electron will be loosely bound. If electron is loosely bound, then ionization enthalpy will be less because you can easily remove electron. And if ionization enthalpy is less energy is required, to remove the electron. In this case, energy band gap will reduce. काची है ये? Any doubt, guys? Any doubt, guys?
No, sir.
No, sir.
Okay,
No, sir, no.
good. So, effect of temperature. If you change the temperature, what will be the impact? Varinder, Channa, and Pratigya.
Yes, sir.
Guys, am I audible?
Yes, sir.
Yes, sir.
Now you have better quality of voice.
Yes, sir.
Yeah.
Yes.
So when we see effect of temperature at 0 Kelvin, you will see all the covalent bonds are very strong, no free electron, and it is perfect insulator. I think I already added this here somewhere here. Yeah. At 0 Kelvin temperature, semiconductor act as perfect insulator. Why perfect insulator? Because covalent bonds are very strong. So I will write here. Covalent bonds are very strong. And that's why at 0 Kelvin it is perfect insulator. Semiconductor act as perfect insulator. Pratigya, if I increase temperature in case of perfect insulator, what will be the impact of the temperature?
Resistance increase होगा.
Bond will break, resistance will decrease, and conductivity will increase. Any doubt? One of the
No.
difference between the semiconductor and conductor is in case of conductor, you will see what is the region of current, Varinder.
Yes, sir.
What is the region of the most, what is the region of current?
Electrons and holes.
Electron movement, only electron movement in case of conductor. But as we are talking about this chapter semiconductor, Chandana, what will be responsible for the current?
Sir, electron and holes.
Yes. So that is the difference. In case of conductor, current is only because of the electron movement. But in case of semiconductor, current is due to both electron and holes. Correct? Electron and holes. But what happens? Electron will be present in the conduction band and holes will be present in the valence band. Okay. So that's why current because of this electron will be known as the electron current, and current because of the holes will be known as the hole current. Correct? This will be the electron current, and we will represent by IE. And this is hole current. That's why we will represent this IH. Okay. In this whole topic, we will talk about electron current and the hole current. Okay. That's why you need to compare between the electron and holes. What are the difference between these two? Here you have property. At one place you have electron, and another side you have holes. Because this is one concept you are reading for very first time in physics topic. All other things are correlated, but this is the one where you have difference. Example, band. You will see the band in current. If there is current, which band will be available in case of electron? Here we have conduction band, and it will be present in the valence band. Any doubt? Second, current. How current is formed? Here, current is formed because of the electron. So, electron current. Here, current is formed because the holes is the hole current. Okay. Then, charge carrier. What is the charge carrier in this case? So, in case of electron, electron will be the charge carrier. In case of holes, hole will be the charge carrier. I'm talking about this current. In electron current, electron is the charge carrier. In hole current, hole will be the charge carrier. Okay. Any doubt?
No, sir.
So, because here you will get question from this, especially in the semiconductor also. They will give the number value, and you have to tell how the things change when there is a semiconductor and number of hole will be given to you. Okay. Example, we know at 0 Kelvin, semiconductor act as insulator, but at room temperature, uh, Sarah, what is the value of the room temperature?
It's around 298.
Yes, around 298 Kelvin, correct, or 25 degrees Celsius temperature. So, at this room temperature, you will have some thermal energy. And whenever there is thermal energy, what will happen? Some electron can get excited and jump to the conduction band. Here, electron will jump to the conduction band. It will convert to the conduction band. And when it moves to the conduction band, you know there will be the three electron and three electron can move. But remember, there are limited number of electrons, not many electrons you will have in this case. Right? So that's why when electron move to the conduction band, what will happen? It will create hole also. Any doubt? Any doubt, guys?
No, sir.
Uh, Example, you have this solid, and now you connect this solid with the battery, and now you want to see ki if battery is connected to this solid, how particle will move. Definitely we have semiconductor here, because the whole chapter name is semiconductor. Remember, when I am not mentioning what is the material, you have to consider semiconductor only. Example here, I said at 0 Kelvin, it will act as a perfect insulator. It is incomplete state. But you have to imagine when I'm saying, I'm trying to say semiconductor act as perfect insulator. Make sense? So this is how you have to correlate when I'm saying, okay, at 0 Kelvin, it acts as perfect insulator. What act insulator? Semiconductor act as insulator. Correct? So, example, here you have battery. You know, bigger one is the positive side. This one is the negative side. So when current pass through this, then same charge will repel each other and opposite charge will attract each other. So it means this side is positive and this side is negative. So can we say electron will try to move toward the positive side and holes will try to move toward the negative? Make sense?
Yes, sir.
Correct? So that's why we'll say if you see current here in the semiconductor, this current is because of the both electron as well as current of the hole. Because when holes are moving, they are also responsible for the current. Right? Because here number of free electron is equal to the number of the correct. So current is because of the doubt and our intrinsic semiconductor is done. Tell me guys, any doubt?
So
Any
with the
doubt in the intrinsic
the
semiconductor?
room at room temperature.
At room temperature, there will be electron and hole, but very few. In 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 this case, what you will see, there are very few electron and holes. That's why you will see at room temperature, current value will be very low. Current value will be very low. Why current value is very low? Because in case of current value, what will happen? Uh, there are less number of electrons because temperature is limited. Okay. So tell me guys, if you want to increase the conductivity, what you can do? Pratigya, if you want to increase the conductivity, what you can do?
Again, repeat, please.
If you want to increase the semiconductor conductivity, what you can do?
Add impurities.
Yeah. So what will the impact of the impurity?
Silicon.
Yes. Your voice is breaking a lot, Pratigya. Extrinsic or impure semiconductor. हाँ सारा दिन खाली ये बैठा है और ये काम है इसमें. Okay. So when we talk about extrinsic or impure semiconductor, why do we need this material? Answer is we know in case of intrinsic semiconductor, uh, in, uh, conductivity is very low. If we want to increase conductivity, we have to impurity. Add impurity in this small amount. And when we add impurity in this small amount, what will happen? There will be huge difference in the conductivity. Ultimately, conductivity will increase. Right? Conductivity will increase. So the process of addition of the impurity is known as Brinder. I will add here only. Brinder, the process of addition of this impurity is known as
Doping.
doping. So doping is the process of addition of impurity. Why we are doing doping? To increase the conductivity of what? Semiconductor. Because we are talking about semiconductor. Correct. So if you see what is extrinsic semiconductor, we can say extrinsic semiconductor are the pure semiconductor with impurity. As simple as that. Correct. So whatever chemical or material added in the impurity is known as dopant. So if somebody asks what is dopant, dopant are the material or impurity added in the chemical. So the impurity atom is known as dopant and process is known as doping. And the process is doping and atom that is impure known as the dopant. Any doubt?
No.
Uh, Chandana, why we are not increasing temperature? Because we said if we increase temperature, uh, then conductivity will increase. Why we are using doping method? It belong to usually either group 13 or group 15. Chandana, why we are not increasing temperature?
No, sir, I'm not sure.
Because practically it is not possible. Example, we know at room temperature it is very less. And now if you increase temperature at 100 degrees Celsius or 70 degrees Celsius, you have to constantly maintain this temperature for long time, for lifetime. And we know it is very expensive. Okay. That's why we can increase the conductivity of semiconductor by doping even at the room temperature. Okay. That's why we can use this semiconductor at room temperature very comfortably. Okay. So that's why what is the benefit of this doping method? In case of doping, semiconductor can be used at room temperature. So we don't need to increase the temperature. And you know, if you want to increase temperature, you need a lot of energy to invest. So that is the advantage. You don't need anything. Okay. The best part is you can use doping in a very small amount, still it will create huge difference. Okay. Whenever we use doping, there is some property of the dopant. Whatever material we are using, they should have some property that is aligned with the our material. Because example, if you are adding dopant and it does not increase the conductivity, what is the use? Nothing. Right? So that's why everywhere we should have some property. Example, if you are using in genetics, pea plant or Thomas Hunt Morgan used this Drosophila fruit fly. Correct. So why we are using only those? What is the specialty? Because short lifespan, easy to grow, easy to observe, demarcation between male and female easily. So when you understand this property, it becomes easy for you to utilize the specific material. Are you observing how I am adding biology in physics? प्रतिज्ञा
हाँ सर।
क्या बोलती है पब्लिक?
आप तो जीनियस हो।
सारा डू यू नो
सच्ची में
ये तारीफ नहीं है?
सर मैं दिल से
नहीं 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 नहीं, नहीं। दिस इज लेग पुलिंग। हाँ सर, आप तो बहुत ही ज्यादा जीनियस हो सर।
नहीं सर, सच्ची में।
Okay, so come to the topic. The reason being, we should know why uh, we are using specific material and what are the property of this material so it does not distort, does not affect the original structure. At the same time, give us a desired result. That is the ultimate thing. Correct? So in this case, what we see, the dopant should not distort the original pure semiconductor lattice because if you change the overall structure, then conductivity will also affect. So it should not distort original structure. Otherwise, what will happen? Overall structure will change. Correct? Then size of dopant, whatever we are adding, should be almost same as the
सर डिस्टॉर्शन मतलब
same as semiconductor atom. हाँ प्रतिज्ञा,
मतलब फर्स्ट लाइन लिखे ना, शुड नॉट, उसके
distort
बाद
original structure of semiconductor.
मतलब
कि जो मेन स्ट्रक्चर है ना उसमें बहुत ज्यादा चेंजेस ना हो. देयर शुड नॉट बी drastic change in the shape and structure of the semiconductor. Otherwise, the overall property will change. Ki example, if you are making a house, then you can do slight change of the repair and you can make it better. But you can't completely change the shape. Otherwise, you have to start from the scratch, or otherwise it will be expensive. Correct. Second, the size of the dopant should be same as the semiconductor atom. Why? Because if they are same size, they can easily adjust and replace the thing. Correct. And third and most important thing, this dopant should give either holes or electron. Why? For conduction. Because we want to increase conductivity. So we want more number of electrons, especially or holes, so it increase the conductivity. Any doubt?
No, sir.
Now we are coming up with the most important topic. 100% you get question in the NEET as well as board. So Sarah, you will get Chandana, you got N and P type of semiconductor last year in any form,
Yes, sir.
and
Sir,
I told you ki
difference
100% you will
between.
get question. Correct?
Yes, sir.
I told you last year ki 100% you will get question.
Mm.
Let me check if this PDF. So I will make difference how we did last year on the new things. So there will be again three three column. One is property, another is N type semiconductor, and P type semiconductor. This is property. properties N type semiconductor and P type semiconductor. So first property is nature of dopant. In this case, we add pentavalent impurity. It means atom have 5 electron and it is trivalent. It means 3 electron. Second dopant group. Which group dopant are added here? Here group 15 and this is group 13. Any doubt?
No, sir.
Then energy level. It will be close to conduction band. So electron can easily move toward the conduction band very easily. But here you will see it will be close to the valence band. So that's why conductivity you will see is slightly less in case of P type of semiconductor. Okay, I'll draw the diagram because diagram is also important in this case. So uh, so example energy level band is extremely important. How? Example, if you have conduction band, this one, CB conduction band. Here you have valence band and there is some energy gap. Okay. But in case of N type, electron energy level will be very close to the conduction band here. Okay. This is the energy of D, means dopant. Energy of dopant is very, very high. So this electron can easily jump from here to here. So energy requirement will be very, very less. But if you see in case of P type, example, this is the conduction band. This is the valence band. Here energy level will be very close to this. Then you know you need very, very, very high to energy of dopant to move electron from the at that energy level to the conduction band. Any doubt? And
No, sir.
that's why this level is known as a donor level because it can easily donate electron and move to the conduction band. This energy level is known as acceptor level because it holes accept electron and then becomes stable. Understood? Acceptor level. So that's why, and you know, I will add fourth point in this energy level of dopant. So here energy level is donor level, so it can easily donate the electron, and this one is easily accept electron, acceptor level, easily accept electron because holes accept electron. Okay, so here extra charge carrier, or in general charge carrier, because in pentavalent group 15 impurity are added, 5 electron are added, but we need only 4. So here it is electron, here it is holes, electron and holes. Okay. Next, if you see what is the energy required for the fifth electron, it is very less. Uh, if you see in case of silicon and germanium, example, in case of donor level, it will be like 0.05 electron volt in case of silicon, and same energy level for germanium will be 0.01, because in case of germanium, energy requirement will be less. I already told you, the bigger the size, less energy is required in this case. Okay. But if you see energy level in this case, it will be very close to the valence band, 0.01 electron volt. But remember, it is close to the valence band. These two are the close to the conduction band. That is the difference. Understood? Any doubt, guys, as of now?
No.
Okay. So whatever will be the free electron concentration, that will be decided by the donor impurity in case of N type and acceptor impurity in case of P type. Correct? Any doubt? So in this case, when we said charge carrier, na, charge carrier concentration, charge carrier concentration, case, number of electrons will be way higher than the number of holes. Number of electron is higher than the number of holes. Here, number of holes will be higher than number of electron. Majority charge carrier, what is the majority charge carrier? Instead of external, you can write majority charge carrier. It will look, and even you will see everywhere same word, majority charge carrier. Correct, Chandana?
Yes, sir.
Majority charge carrier. Okay. Next, total current. What is the reason of the total current? Here we know in N type of carrier, total current is mainly because of the electron. We know total current is equal because of the electron plus holes, but actually it is mainly because of the electron. This is the important. Okay, here current should be because of both holes as well as electron, but it is mainly because of the holes. Mainly because of the holes. Then it overall nature, overall charge on semiconductor, both will be neutral. Why? Because it is compensated by the another molecule. So overall, both will be neutral in this situation. Okay. And next is minority charge carrier, because we know majority charge carrier in this case is electron. Here it is holes. What is the minority charge carrier? Like there will be small current because of the other part also. Eh? This is full. Oh, minority charge carrier. If you have majority charge carrier in case of n-type electron, then minority will be holes, and here minority will be electron. Understood? Any doubt, guys? But
No, sir.
still one more left because Chandana, you told me ki we did 10, so we'll do 10 here also. Examples. What are the example of N-type semiconductor? Remember group 13. So all the element of group 13. It means bangan, aloo, gajar in thali. Okay. And oh, I did ulta na. I guess yeah. Here it will be group 15 element. So it will be here. And here it will be group 15 element. Nana, Pategar, Aswarya, Sab, Bindas. Anything we missed from last year, Sandana? Was it same thing? Chandana, we missed anything important?
No, sir.
Yeah. Even I can make 11 this time because every year we are improving now. So we have to do better than last year. 11th point. See, like, what is the main charge carrier concentration? So we know main charge carrier concentration decided by. In this case, it will be decided by the donor impurity. Donor impurity will decide what will be the electron carrier concentration. So number of electron will be equal to number of donor atoms. Very important for your competitive exam. For board, this is not required. But for competitive exam, for numerical purpose, this will be the most helpful thing. And here, it will be the acceptor impurity. Here, it will be acceptor impurity. So you will see number of holes. Number of holes is equal to the number of acceptor unit. Trust me, very, very, very important for your competitive exam, both the things. And we'll solve question from that. Okay. Let's grow very fast and add 12th point also. The 12th point is charge on impurity. Here impurity have +5 charge and here impurity have +3. Semiconductor have +4. Correct? Any doubt, guys? And we did this. And it's your choice whether you want to write for the board and or competitive exam. But my personal opinion is there is no difference between the board and competitive exam except if you have to derive any formula. Like if you have to derive each and every formula in detail, that make difference. I do agree. But other than that, in any normal topic is exactly same. What you need to do, whatever topic you are doing, if you do theory perfectly, you will never face issue in the numerical. And then after doing theory perfectly, solve more number of questions. Because in board, we are getting objective questions, and in competitive exams, we are getting theoretical question nowadays. So both are correlated. Okay. Any doubt? We are done with the important point, and let me do one, two topic in hardly next 5 minutes, and then theory will be done. We'll solve question from this part. Okay. And next topic name is mass action law. How is it going, guys? You are enjoying the topic, or you feel ki sir energy level is low?
No, sir, enjoy.
The interesting
Very
topic.
enjoying. You are too much enjoying. Yes, other people. Then Pratigya.
Between two and too much.
Between two and too much. Okay. Barinder,
Yes, sir.
कैसी चल रही है क्लास अब तक?
बढ़िया.
बहुत बढ़िया चल रही है.
Yes.
समझ में आ रहा है ना अच्छे से? मतलब ऐसा तो नहीं लग रहा है कि 12th का पोर्शन जल्दी जल्दी खत्म कर रहे हैं.
No, sir, समझा.
हाँ. संजना.
Yes, sir, it is going well.
So, Sara,
Yes, sir. Good, interesting topic. it is.
was it taught in your class? कि okay, how impurity are added?
Yes, sir. Like not in detail though.
This table was not made in your class.
It was, but not so many points.
Okay, because
Like
remember,
about 5
for
points or
5
something.
marker, even if you write 6, 7 point, this is good enough. Even 5 point is enough. But even I know you can't remember all of them. You will definitely miss 2, 3 points. So at least you have opportunity ki you can write. And the second thing, we are not going out of this syllabus, not going out of the box. So that's why it will be helpful. Last topic of this topic, then it will be a, like relatively new topic, P and N junction together. And for this P N junction, you need this type of understanding. Come to the law of mass action. We know that at room temperature, density of hole in the valence band is mainly because of the what you say extrinsic semiconductor. Because at room temperature, normally there is no conductivity, right? Almost negligible. But conductivity increase as you add extrinsic impurity. Make sense? So you will say key rate of generation of charge carrier, how many charge carrier are produced. Because what is happening, you add example, there were 10 silicon atom. Now you add one nitrogen atom or one phosphorus atom. Let's take phosphorus because very close side. So if you take phosphorus atom, both sides is almost similar. You need four electron to form covalent bond and a stable structure. But now you have one extra electron. This extra electron will move to the different place and holes will produce and electron will move further. Then in next place it will go, it will fill the vacancy and electron keep on moving. And when electron keep on moving, it is responsible for current. Okay. So rate of generation of charge carrier, whether it is electron or hole, is equal to rate of recombination of charge carrier. Is equal to rate of recombination of charge carrier. What is the meaning of recombination? Example, recombination of charge carrier. Example, one electron is moving ahead and hole is formed because of the vacancy of electron. Example, you had electron here, but due to some reason, this electron leave the place and moving outside. So what will happen? There is vacancy. This vacancy is known as hole. Now this hole want to become stable. What will happen? Other electron will come and try to fill this hole. Other electron will come and try to fill this hole, and again it will become a stable atom. This process is known as recombination. Tell me guys, any doubt? Again, electron and hole will combine and make a stable molecule. Yes or no?
Yes, sir.
Yes.
So that's why you will see total number of electron multiply by total number of holes will be equal to intrinsic and scalar, because ultimately total number of atom remains same. Total, that's why it is neutral overall. Even if you add n type or p type, it is neutral, because ultimately it number of electron will be equal to the number of holes. Okay. And when we are saying Ni, you know Ne means number of electrons, and that's number of holes. What is Ni? Total number of atom overall. So you will see in this situation total number. I means intrinsic, internally. It depends upon the nature of semiconductor. It means if you take silicon and germanium, value will be different. Why? Because in case of germanium, electron can easily move. In silicon, small atom, they will move like with almost negligible, not negligible, very slow rate. Carbon negligible rate, because carbon atom size is so small that it is stable. Understood? So this Ni number depend upon the nature, depend upon the nature of semiconductor. It means if you take silicon and germanium, value will be different. It depends upon the temperature. Why? Because if you increase temperature, more number of charge carrier will be available. Correct? More number of charge carrier available. But it does not depend upon the doping level. But it does not depend upon the doping level. Does not depend on doping level. Whatever the impurity you add, overall number of atoms remains same. So very, very, very important point for your competitive exam. Does not depend upon the doping level. Does not depend upon the doping level. Same point here. Number of hole is equal to dopant. Number of hole is equal to this. Okay. To understand this, let's do question. And now we'll do PYQ also. First question. Pure silicon. Write it down. Pure silicon at 298 Kelvin temperature has equal number of holes and electron. Equal number of holes and electron, that is equal to 1.5 into 10 raised to power 16 per meter cube per unit volume. Okay. Doping of gallium increased to 3 into 10 raised to power 22 per meter cube. You have to calculate total number of electrons in the doped silicon, because you are doing change in the silicon. That's why silicon change, silicon doped. What will be the value? First, write law of mass action. Answer. Mass action law say the total number of electron multiplied by total number of holes will be equal to total number of intrinsic square. Right? You have to calculate total number of electron, then you know total number of intrinsic square divided by total number of hole. So what is the intrinsic? 1.5 into 10 raised to power 6 square. So can we say it will be this? Divide by what is the total number of holes? 3 into 10 raised to power 22. Correct.
0.75 into 10 to the power minus
No. This is not 16.
13.
That's why I was thinking it cannot be negative. It is 16. So if it is 16, what will be this value? 32. Minus, it cannot be minus. There cannot be minus electron. Okay. Even if I do mistake, ask me, or if I do mistake, I will correct for sure whenever it will be possible. So what will be the answer?
10 to the power minus 10 meter. 10
Plus
meter.
10, plus 10
Uh,
per meter cube. Done. So numerical from this topic will be very, very easy. We did this. After this, what we need to do is questions, because there are, I think, 10, 15 questions, and all are very, 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 very. What is very, very? Varinder.
easy.
Yeah,
Easy.
very good. Because we did last year and nobody made mistake. That's why I am saying. Otherwise, you will say, ki, sir, you always say ki every chapter is easy. What is this, sir? Ah, check PDF. EM. Ah, hmm. Happens to this. Is screen visible, guys?
No, sir.
Is this visible now?
Yes,
Yes, sir.
Yeah. So you take a piece of copper, metal, and germanium and cool from room temperature to this Kelvin. What will happen to the resistance? Chandana, in case of metal or conductor, if you increase temperature, then your resistance increase. Correct. If you decrease the temperature in case of copper, then resistance will decrease. Resistance of the copper will decrease. In case of germanium, which is semiconductor, so if you increase temperature, resistance will decrease. Now you are decreasing, resistance will increase.
Mm.
Oh, any doubt, guys?
No, sir.
So it means the rule what we did here, same is applied here, and I will mark this point. That's why I wrote multiple time what happened when temperature increase. In case of semiconductor, if you increase temperature, resistance decrease. Correct. Same thing we did here when we did table. Where is the table? Yeah, correct. In case of conductor, temperature increase, resistance increase. In case of insulator or semiconductor, if temperature increase, resistance will decrease. Any doubt?
No.
No. Next. Sarah, at absolute zero temperature, silicon act as
Insulator.
exactly done. See, at low temperature, they act as insulator. Where I wrote this. See, perfect insulator at 0 Kelvin. So whatever I mark in this special box or pink color or anything that sort, it means it is really important and what they can ask. Then, but in the intrinsic semiconductor become insulator at
Option B.
very good, correct. 0 Kelvin it act as insulator. But in the Pratigya, P type of extrinsic semiconductor is obtained by when germanium is dropped with no option for you. Pratigya,
Sir.
anything from bangan, aloo, gajar, in thali.
Okay.
Anything from that will be the answer, right?
Yes,
Or you
sir.
can say if option could be given like group 13 also is correct. Or where holes are charge carrier. That could be answer, right? Make sense?
Uh, Boron.
They always be ahead of your question. Remember, this is the rule. I told you in the biology part. Ki always be ahead. Try to answer always whatever maximum information you can add in your answer. You will be always ahead of the examiner. Example, Chandana. Electron concentration in N type of semiconductor is same as the holes concentration in P type. And whenever external field, electric field is applied across, then what will happen in case of N and P type?
So current will flow in N type.
You need option in this case. So I will show option.
So this is
You have normal level in an NP type. Now you apply external field, compare the current.
so the N type is greater than P type.
N type is greater than P type because electron mass is less, so they can move fast. N type current will be greater than the P type. Any doubt?
No,
Reason?
sir.
Because in case of electron, mass is less, so movement is fast. Mass is less, so movement is fast. So we can add this point as well. This you will study in the current chapter, mobility, new. So you know if you compare electron and hole, then electron have more mobility, ability to move, mobility, ability to move. So less mobility. So logically, if everything is same, then current because of the electron will be higher than the current because of the holes. And because this is PYQ. So next, Sarah, in P type of semiconductor, what happened? What is the majority charge carrier and minority?
The holes are majority carriers
No,
and
P
trivalent
positive holes are majority charge carrier, correct? Next, and dopant.
atom.
Yes, holes are majority and trivalent atom are the dopant. Done. But in the N type of semiconductor, which statement is true? Opposite to the sixth question.
Option B.
Option
Option
B.
B, correct. Minority charge carrier is holes, majority is electron, and pentavalent is the atom. So whatever we do in the table is working for your NEET also. But a small amount of antimony is added to the germanium. What will happen? See
See,
why? This is N type antimony. It is donor level, not acceptor level. Uh, there will be more free electron. That's why current is there. There is no impact on the resistance because we are not changing temperature. Almost same thing you have here, Chandana. Pure silicon, this temperature, equal number of hole, and this is the value. If iridium is increased to this level, what will be the doped semiconductor in this case? Iridium. So number of holes is given. You know number of electron will be number multiplied by number of holes will be equal to intrinsic square. So number of uh, electron in this case will be what is
So
holes?
5 into 10 power 9.
Same question, huh? 32. Exactly same question, huh?
Yes, sir, but
sir, 4.5 वहाँ 3 दिए
number of moles value is different.
22. So this 3, this zero point 0.5. It will go up 0.5 into 10 raised to power 10. Our answer is D. Any doubt, guys? So this formula is, I told you, important for your exam because we did question based on this same question. So this. Sarah, which of the following statement is false? Is this correct? Trivalent and p-type.
So,
Majority charge carrier and are holes. Is this correct?
no, sir.
Electron. N means negative. It means electron. And then 5. N means nitrogen family. Okay. Minority charge carrier in p-type are electron.
Yes, sir.
Opposite to the other n-type. And last, resistance of the intrinsic semiconductor decrease with increase in the temperature. Correct. So now you feel ki even it look like it is for a board like table, but everything is working. Ki what is the majority charge carrier? What is the energy level, donor level, acceptor level in last question? Pentavalent impurity and trivalent impurity group. And as of now, what then minority charge carrier we had this question. Of course, example they always ask, but we didn't get question from the acceptor level. Okay. So, Varinder, which of the following act as impurity to produce N-type? Phosphorus, nitrogen family. N-type means nitrogen family, right? ठीक है P-type of germanium semiconductor it must be topped with. जल्दी जल्दी बोलो जल्दी जल्दी.
Yeah.
Chandana, when arsenic is added as the impurity to the silicon, what will the resultant material? N-type, pentavalent, majority charge carrier electron, minority holes. It could be probably from this, but they asked the easiest one. Sarah, which of the following added as the impurity into the silicon produce N-type?
The phosphorus.
Varinder, N-type of semiconductor is heated, so what will happen?
Sir, option A.
It always remains still. It, because electrically neutral, no? Correct? It is electrically neutral, so that's why you will see key it should be overall same. Am I right? Anybody have doubt? Varinder, no, but there is one option. Electron and holes both will increase, na? Oh, both number is same, but both will increase because if you are increasing electron, holes will also increase. Any doubt, guys?
No, sir.
No, sir.
Neutral, that's why same. Neutral, that's why remains same. But overall, both will increase. Overall, because you are adding extra electrons. So basically, you are increasing electron at the same time, holes will increase because electron will move. Okay. So tell me, was this topic extremely easy? But I said very, 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 very easy. Makes
Yes.
sense? So in today we did not finish, but you will get question from this topic also in today's exam. Okay. See you then. Is it enough? Or because you have a lot of syllabus this week, correct? So prepare well, ask your doubt, send your doubt. I will make sure ki it will be corrected and I'll tell you the answer. I got notes from Pratigya. Send your notes.